Namaskar. Now let's see about determinant. What is determinant and how to calculate the determinant of a matrix and what are the orders and how to expand them. So let's see all these things which we'll discuss in this lecture. Let's begin. So as you know, as you remember that whenever we represent a matrix, we represent it A is equal to some elements Aij and it is a M cross N matrix, right? So whenever we are going to talk about determinant, we will just talk about the mostly the square matrix, which will have a square. It means that M is equal to N it would have, and that is where we have the determinant defined, right? So it means no, when we talk about determinant, then it would have a various orders, order 1, order 2, order 3. That we will see what is that in the moment. But before that, no, each matrix, if it is there, then we can have a determinant, and the determinant of a matrix is written like no, it is not mod. It's the kind of mod symbol, but when it is associated with the matrix, then it is said to be determinant. So we also write it as a determinant A. So that can have a value, right? A value of a complex. It can be a complex number, or it can be some real number, right? So it can be anything, and mostly here we are discussing about real numbers. So mostly we'll get a real number at the output. So it means that each and every matrix can be associated with some kind of real number and or a complex number, and the value of that would be called the determinant of that matrix, right? So for example, let's say if you have a matrix A, B, C, D, then the determinant of A, you can write determinant A, or you can write like this determinant A. Remember, it's not mod, it's the determinant A, and this would be equal to your instead of use this kind of big bracket, you just have a two perpendicular line kind of thing, and that would be representing determinant, and this should be written similarly to that, right? And now remember, if you associate it with our beginning chapters, if you want to write it in the terms of function, so you can assume that there is a set of matrices M, for example, it is have all the set of all square matrices, for example, set of square matrices, right? And then you can associate always this to a set of real numbers. So let's say K represents the set of complex or real numbers, right? Then you can define a function from M to K such that you have Fa is equal to K, where K is the element of K and A is the element of square matrix set M, right? So in such case, the function this value is called determinant A, right? Determinant A, the value of that. So this is what the determinant, if you want to define in terms of function, we talk in a broad range and represent it. So this is about that, what is determinant and how a matrix, same matrix can be represented as a determinant, and each determinant may have is associated with a complex number or real number or some value to that. So now let's see how we can find those values for different determinants and for the different orders, and how to expand them. So let's see. So first of all, let us talk about the determinant of order 1. Determinant of a matrix, right, of order 1. Order 1 means let's say if A is a matrix and it have only one element, right? So it will be of order 1. And right, and the determinant of A for this matrix, determinant of A, or you write determinant A, that would be the value, the element of it would be the value of such kind of matrix, right? So for order 1 matrix, the determinant of A here it would be determinant A and is equal to the same value. Now talking about the determinant of order 2, determinant of a matrix of order 2, right? So in this case, for example, let's say you have a matrix something like A11, A12. Remember, the first digit represents the row number, the second digit is the column number, A22, right? So this is a 2 cross 2 matrix, or you can say a matrix of order 2. So its determinant can be written as how? It can written as determinant A or determinant A. Mostly I will use this symbol, and then you can write it as or you also represent it as delta for some time, and then you can write it in no, the curve, the bracket would be something like this, A22, right? And now talking about that, the one real number associated to how to find that value. So for finding that value, you can multiply this element with this and this element with this, and the value take a difference. So for example, you can write delta is equal to A11 A22 minus A21 A12, right? So this would be the value of this determinant of this matrix, and this would be calculated using that. For example, let's have an example for this example. So let's say you want to evaluate determinant 2, 4, minus 1, 2. So this value will be equal to what? 2 into 2 minus 1 into 4, and this can be written as 4 plus 4 and is equal to 8. Right? So you see this value is associated with one single number, that is a number associated with that matrix. All right. So now let's say this is order 1 and order 2, and now we can talk about the higher order 3, 4, but will not go beyond order 3 for the time being here. That will be enough to give you understanding. But when we are talking about order 3 matrix, then then we can expand that the determinant for that 3 order matrix, the order 3 determinants towards 2 order matrix determinants, and then we can follow this calculation. Now we have some ground rules that how to expand a determinant of order 3 or higher towards the second order or lower order for finding the value associated number related to that determinant. To see how to find it and what will be the method we should follow for that. So determinant of a matrix of order 3 cross 3, right? So let's say you have a matrix A, which is A11, A12, A13, A21, A22, A23, A31, A32, A33, right? So this is the matrix you have, which is a 3 cross 3. So if you want to find a determinant for it, so how will get it? So it will be determinant like this, and this will be written as A11, A12, A13, A21, A22, A23, and A31, A32, A33, right? Now to find the value for determinant for this, you should expand this determinant. And how to expand it? For example, you can expand with any row. So this is your row 1, this is your row 2, this is your row 3, as you remember from our previous discussions. This is column 1, column 2, and column 3, right? So it has 3 columns and 3 rows. So you can expand this determinant along any row or any column, and they will give you all the same value, right? And now talking about how to expand with respect to a given row. So for example, you take, let's say I want to expand across row 1, right? So you follow this row, and then you choose the same column. Now to expand that, you choose and get a sum of all those values for A11, A12, and A3 like this. So for example, you start with the first element A11, and then you write -1 to the power the indices. This is Aij, right? So the Ai plus j, so here 1, 1. And then you write this value, the one which is expanding. So whenever, whichever row you follow the element, you don't touch any other element, and the remaining elements like this, you see this one, this part. So this part will be multiplied with this. So it will become A22, A23, A32, A31, A33, right? So for this element, the remaining leaving this row other elements and same column elements, and you can expand this. Similarly, you follow for the in this row the second element, and then you follow the same process. So you write -1 to the power plus, and here you can have -I plus j, right? And then you leave this elements which is in this C2 column and the row 1, and rest write the determinant corresponding to that. This is -1. So it will be like you leave this, so you will be left with 2, 1, 2 3, and you will be left with A31 and A33, right? Now do the same thing with the third column. So you add again, and then you take A13, and before that you take minus 1 the indices A plus J, right? So here I plus J is like 1 plus 1, here it is 1 plus 2, and here I will have this A1 2, right, where you are multiplying. So it will be 1 plus 2, and here 1 3, right? So it will be 1 plus 3, and you leave this now and this, and then you are left with this much, right? So you are left with A21, A22, A31, A32, right? Okay. So this is that you can do the same for other. So for example, instead of doing with expanding with respect to row 1, I can do with row 2 also, or row 3 also. But before that, let's see that expand the value and what value you are getting. So here it will be minus 1 to the power 2, so it will be square, so it will be written as A11, and this will be determinant here, A22, A23, A32. Now you see that how 3 cross 3 is expanded in terms of this 2 order determinant. Now here it will become 1 plus 2 is equal to 3, so it will become minus 1 here, and then minus A12, and then you write this determinant A21, A23, A31 here, A31, A33, right? Similarly for this, so it will be 3 plus 1 4, so it will become plus A13, and here you can have this A21, A22, A31, A32, right? Now you know that how to expand the these second order matrices, so you can follow that. So it will become A11, and here it will become A22 minus A22, A33 minus A32, A23 minus A12, and here you can write A21, A33 minus A31, A23. Here you can write A13, A21, A32 minus A31, A22, right? Now you expand that full, and you can have A11, A22, A33 minus A11, A32, A23 minus A12, A21, A33 plus minus minus plus A12, A31, A23 plus A13, A21, A32 minus A13, A31, A12, right? So this is what you get determinant A for that when you are expanding with respect to row 1. The same thing you can do with the row 2 as well. For example, you just saw here you expanded it with row 1, so you can do the same thing with A2. So how it will look? So let's see for expanding it. So let me write it again. The determinant A is how it is: A11, A12, A13, A21, A22, A23, A31, A32, A33, right? Now I want to expand with respect to R2, right? So how will I do? I will just leave behind this row anyway, and will take the remaining. So when I'm taking the first element of it, so I have to read the column 1. So this will be written as for this A21. So first of all, it will be minus 1 plus minus 1, and I plus j is equal to 2 plus 1, and this will become A21, right? Now I will leave all the elements in this row and this corresponding column, and I will keep the other element in this remaining order row. So it will become A12, A13, A32 and A33, A32 and A33, right? Similarly, you do for this row the other element like this. So it will become minus 1 plus, here you write minus 1, I plus j is 2 plus 2, and you write A22 and the remaining elements, right? So now you leave this and this, so you will be left with this, this, and this, right? So it will be A11, A13, A31, A33, right? Now you further expand with respect to this, so this will become minus 1 to the power 2 plus 3 and A23, and then you will have a leaving this and this row, so it will be left with this, and this, right? So it will be A11, A22, A31, A32, right? So now you expand the same way and you will find that the value you are getting here, it is going to be the same value you are going to get here. So it means that either you expand with respect to this or this, you are going to end up with the same value. So it means then whatever whenever you want to determine the determinant, you can follow any row or any column and you can expand that row and column. Similarly, for example, if you want to expand the same determinant with respect to some column, right? So let's say this determinant is A11, A12, A13, A21, A22, A23, A31, A32, A33, right? So I can no, instead of that row, I just want to expand with this column C1. So how I'll do? So again, I'll follow the same rule. I will take -1, and let's say I am expanding this column. So I'll take this element, and this element, and corresponding expansion with that, and we'll expand it. So let's say with the first one, so we'll leave this row and this column element, and write here -1 I1 plus 1 A11, and the remaining. So the remaining is this, right? So it will be the determinant of the two order A22, 23, A32, A33, right? And then again I will take a -1, and now the second element of this column is this. So this will be -1, 2 plus 1, and here write 2, 1, and the remaining element should be that. So it means I will leave this and this. So I will be left with this one, this one, this one, and this one, right? So I will write A12, A13, A32, A33, right? Similarly for now the third element in this, so the third element is this one. So when I'm taking this one, so I have to leave the element of this row and this column. So I will be left with this, right? So it will be 1 minus the indices ij, 3, 1, 3 plus 1, and 1, 3, 1, right? Now I leave this element and this element. So I will be left with this and this, right? So let's have, so this and this will be left out. So we'll be living with A12, A13, A22, A23. Now expand this further, and then we will end up with the same value. So you see that you can expand that with respect to any column, any row, to find the determinant of the given matrix of order 3, where now you see that how I expanded order 3 determinant to order 2, and then they can be determined associated with a single real number or complex number as per the entries or the elements of the determinants. So this is about expansion. Now utilizing this feature, like you can expand it with respect to any row and column. So obviously when I want to minimize my calculation, so I choose a row or column which have number of zeros high, right? So the first point, whenever you want to expand a determinant, so always choose, because you have a freedom, either you choose any row or any column with respect to that, expand it and determine the determinant of that matrix. So you will get the same value. So obviously to minimize the calculation, I will choose a row or a column which have a maximum number of zeros. So that way we'll have a minimum time required to calculate the such determinants. So this is one property you should utilize from here. Now another property associated with that you should remember, and how we can find many other values which, if they are such kind of relation. So let's see what it is here. So for example, let's say you have a matrix something like this, 2, 2, 4, 0, right? And then another matrix 1, 2, 1, 0, right? So you can easily see that here you take out 2 common from each element in the matrix. If you remember, so it will become 2, 0, right? Which is equal to B. So it is equal to A is equal to 2B, right? So you can easily find this relation from our earlier understanding from the matrices. Now if you want to get the determinant relation for this, so what will be the determinant A? It can be written as 4 minus 0 minus 4 into 2, right? So it will be -8. And what will be the determinant B? If you want to find the determinant B, so what we can write? So we can write 0 minus 2, it will become -2. So you can easily see that if you get the determinant relation here, so you can see that it is equal to determinant A is equal to 2 the power square determinant B, right? So you see that the relation here, if matrix relation is A equal to 2B, but when I am talking about relation of the determinants of that value, so it is coming to the power 2 order, right? So it is the 2 is what? It is your order of the matrix, right? So here it becomes 2 to the power n determinant B. You can see that where n is the order of the matrix, right? So see a unique relation you got. For example, if a matrix is related with this kind of relation, the determinant, their determinant will be related with of the order of matrix to the power n determinant B. So that's a very unique property associated with the matrices. So for example, you have a matrix K equal to KB. So their determinant relation you can write A equal to K to the power n determinant B, where n can be 1, 2, 3, whatever the order of the matrix you are going to follow. So that's a very nice important property which you can find from this kind of studies. So that you remember, that's a very nice formula which we sometimes need it during calculation, which makes our calculations much faster. Now let's have a very good example with that, and then we'll end this chapter in this part, and then we'll proceed further. We'll discuss the properties of matrices in the lecture. So let's see an example associated with that. So for example, you are given that you find the value of x such that the determinant 3x 1 is equal to given is equal to 2, 4, 1, 2, right? So here remember here it is not matrix that you can just compare the values, right? From the beginning in the matrix, you just, if the two matrices are equal, then each element will be equal. But here it is determinant. You remember that is not the same thing as a matrix. We are just talking about the values. So here we have to determine. So it will be 3 minus x square is equal to 3 minus 8, right? 4 into 8. I multiply like this and this. Similarly here this and this. So it will become what you will get. So 3 minus x square is equal to minus 5. Or you can say x square is equal to 5, 3 plus 5 is equal to 8, right? Or you can say x is equal to will have plus under root 8 means plus minus root 2, right? So this is how you can get. And also just to show you that it is not the same thing as determinant matrix. It is no, here if the two determinants are equal, then you have to calculate the value. You don't equate the numbers together, right? So this is that how to find a determinant, how to expand it, how to find the values of 1 order, 2nd order, 3rd order determinants. So this is all about this lecture. Again, let's discuss the properties associated with the determinants, which will make your calculations faster in case of determinants. So we'll discuss that in our next lecture. See you there. Thank you.